All right. This section is about implicit differentiation and the related rates. I'm going to explain and work through the second example for this section. This is a problem of implicit differentiation. So we have a function y defined implicitly by the equation x squared y cubed plus 6x squared plus y equal to 12. So in this equation, y is a function of x, but it's not written explicitly as y in terms of x. It just has a equation mixed with x and y. So in this case, we have to use the technique of implicit differentiation. By implicit differentiation, it means you take the derivative of the equation on both sides with respect to x at the same time, and using the rules we learned for differentiation, and then solve for dy over dx at the end. So let's just proceed with this example. So let's just take the derivative with respect to x on both sides of the equation to start. Okay. So we're going to use the notation d over dx. That is more convenient in this example. A lot of times, usually we use primes, but sometimes we do use d over dx. Okay. So then remember, we have to take the derivative with respect to x for each term on both sides of the equation, and more importantly, when we take the derivative of y, we have to consider or remember y is a function of x. Okay. So then we have to use the chain rule when we take the derivatives involving y. Okay. So let's just do it term by term. So in the first term on the left, we have the x squared, y cubed. So this is the product of two functions, the function of x squared and the function of y cubed. So we have to use the product rule. So let's just write down term by term. Okay. I'm going to write down step by step to start. So take the derivative x squared y cubed with respect to x, and the second term is 6x squared. So we take the derivative of 6x squared with respect to x. So that's the left hand side, and the right hand side, again, we take the derivative from y and 12 with respect to x. Okay. So I just want to write everything in detail so that you can follow me. Okay, so that's the second step. Then, as I said, for the first term on the left, x squared and y cubed both are functions of x, so we have to use the product rule. So if we name x squared as f and the y cubed as g, then the derivative of f times g is just derivative of f times g plus the function f times derivative of g. So let's just do that. Okay, so we use the product rule in the first term. So we got the derivative of x squared times y cubed. outside. Okay. So that's the first term. And then we have to multiply x squared with the derivative of y cube. Okay. Oops. There should be y cube in here. So this is the derivative of the first term on the left. It breaks up into two terms because of the product rule. We have to use the product rule because we know x squared times y cube is the product of two functions. Okay. Now, the second term is pretty straight. We just take the derivative of 6x squared with respect to x. So that'll be 12x. 6 times 2 is 12. And x to the 2 minus 1 is just x to the 1 over x. Okay, so that's easy. On the right-hand side, the first term, dy over dx. Remember, y is a function of x. So why don't we just keep it as dy over dx. So that's just dy over dx. Okay. And the other term is just 0 on the right hand side. Okay, so now everything just becomes straightforward except the first term. Okay, so now the derivative of x squared with respect to x is just 2x. So that's the first term on the left hand side. 2x times y cube. Okay, so y cube. So that's easy. And then we got x squared. Second term times the derivative of y cube with respect to x. So this is a term that we have to pay special attention to. Y cube is a power function. So we're going to use the power rule. So we got a 3. So let me just use parentheses in here to make it neat. So we get a 3 times y squared, because if we use the power rule, you have to multiply the power 3 by the y to the n minus 1. So 3 minus 1 is 2. So that's the first part. But then we know y is a function of x itself. So in that case, we have to multiply the derivative of y with respect to x. That's the part that a lot of people will forget. But it has to multiply the derivative of y with respect to x, or the derivative of y, because y is a function of x. So remember the chain rule. Okay, so this is the second term, and then we got the 12x equals dy over dx. So now let's just simplify the left hand side a little bit. So we got 2x y cube plus 3 times x squared y squared, right? Okay. So you can put the constant 3 in the front. And also we have dy over dx to multiply the whole thing. So that's the second term, and then we got 2x equals dy over dx. Okay, so next we're going to move around the terms to combine like terms. So the like terms in here mean the terms with dy over dx and the terms without dy over dx. So we're going to move the right-hand side dy over dx to the left and 2xy cubed plus 12x to the right. And then we have to change the sign of everything when we move to the other side. So now on the left-hand side, we got 3x squared minus squared dy over dx minus dy over dx. Oops. So that's the left-hand side equals negative 2xy cubed minus 12x. All right, so now almost done. Now we can factor out dy over dx from the left-hand side. So why don't we do that? And then what's left is 3x squared y squared minus 1. Okay, don't forget the 1 in here. Okay, when you factor out dy over dx. And the right-hand side is just unchanged. One more step. So, to solve for dy over dx from this equation, we just divide the equation by 3x squared y squared minus 1. So that's just equal to a fraction or rational function. And the numerator is just negative 2xy cubed minus 12x. And the denominator is just 3x squared y squared minus 1. So that's the final answer for this example.